Really useful insights.
I think there's really two elements, and this is where we start getting into little data. And we kind of define little data as the stuff that's sitting in your business, that's sitting in silos. Heck with it. That was that.
So you're actually the second one to talk about little data, because last night he talked about making data small, then smart.
Small, then smart. How do you make it small? I don't know.
I'm not sure, but that was the...
Okay. Well,
he picks out.
Oh.
Yeah.
He takes
By analyzing
gobs and
it,
gobs
you know,
and gobs
real
and
time.
pulls out
Okay.
intelligence so that it's something
Okay.
you can deal with.
Okay. Well, we'd have a
story and everything, you
we'd
analyze it as a
we'd have a little different definition.
Right.
It's we look at it as the like all your HR files, or your customer records, or your marketing plans, etc. You'll find that companies will have multiple systems that run various aspects within the company. And unfortunately, these are kind of in silos. And before this died, there was a screen that showed silos falling down. What we like to do is take those silos down so that that data can be brought into a single place where anyone can analyze it. And I think that this is where there's a huge opportunity in business, organizations, government, wherever it may be, for breaking down these silos. How many of you in business had spreadsheets that you used to work on all the time? See, everybody has spreadsheets. And it was usually that you have a spreadsheet because the system that the company had bought for doing whatever didn't do quite what you needed it to do. So you'd get the numbers from the system, and then you'd put them into the spreadsheet, and then you massage them a little bit and hope you got the right numbers in, you know, and that was happening all through the organization. Well, what's happened, and the reason that we've seen such a huge opportunity, is that there's now technology where all of that data from those spreadsheets, from the systems, internal information, external information, can be brought together and continually updated in real time. And so it's a different way of looking at data, at big data. As we said, we call it little data. If you then can take that data and put it into a functionality, a dashboard system, let's say, where you can start looking at, I've got to do this, I'm sorry, there's just some great things here.
Yeah, get it started, Russ.
I'll try.
So that's what we focus on, is not so much necessarily the velocity, not so much necessarily the volume, although we can deal with some pretty big amounts of data and do it pretty fast, but we focus on what it all means, how it fits together, and how to make it really useful. So that's what we do as a company. And so, like Russ is talking about, bringing down the silos. So, for example, you know, a company will have their operational system to put insurance policies in. So their agents will type in their policies, and then they'll have another system maybe for HR or for finance. Or for some other business function, and it might be a different computer system. And of course those systems don't talk to each other well, and then there's just data that isn't in any system, that's in people's heads, it's in their spreadsheets, it's in their access databases. That's kind of some of the most important pieces of information in the business, oftentimes, and so that's what we focus on, is going after the meaningful information, which sometimes is tiny, sometimes is a spreadsheet with 10 rows in it, but it happens to be the way that that everybody needs to group the insurance policies or whatever it is they're looking at. and it helps make things simple for everybody. And so we spend a lot of time doing that and making sense of the information and then bringing it together.
And we've started the humor part of the presentation now, so it now works, you know.
There you go. Yeah, it's kind of funny. I mean, it's amazing what we see.
It's amazing, and it's kind of, I think, an indication of how frustrated people are, because you can find so much humor out there on the internet about how difficult it is for people using the traditional spreadsheets and trying to do things what we think is in our way of thinking is the old-fashioned way. And it's a lot of fun when ordinary organizations can begin to actually see. I mean, I made a comment earlier before we started that people start looking at stuff that they didn't realize. We sat down with a group of 4 mid-managers of a company, and we presented a bit of data and said, now how would you handle this data? How would you work with this? We got 4 different answers. And these people work with each other every single day. It's a real indication of that there's a real problem of communications a lot of times in companies. And when you can break those down so that everybody can see what's going on, it's really quite interesting. I think these are the old days. I think that people are beginning to see, and this is why we're really excited about little data. Here's a great example.
Yeah, we see this all the time. So somebody will throw report number 1 there on the CEO's desk. Say, here we are, here's our canceled health policies, which of course we don't want to see. And they'll, put metrics around it and say this is good or bad, whatever. And then report 2 comes along from somebody else, and it answers the same question, and it'll have a different number on it. And that's the result of it. Pretty high frustration level. And we see it all the time. And so that's where we focus a lot of energy on, is helping people come to either a agreed upon definition of what it is they're looking at. In this case, what is a canceled policy and when do we count it? That particular case, one of those reports, they counted it on the day the policy was canceled, and on the other report, they counted it on the day it should have expired. So there's a gap in time. Makes it different numbers, because that's a time-based report. Here's this month's report.
We had an example of a community, and they were publicizing the fact that their town was really taking off. It was doing some great things, and so they were saying our building permits are up greatly. So we're having a big economic boom here. And we took a look at the data, and Joe gathered a little bit other public data and put it together and provided it to the city fathers. And it was amazing. They had never probably ever seen dashboards before. But it was about 12 seconds after we showed them the dashboard, the city manager said, "Holy crap." Because it turns out that, yes, the building permits were increasing, but we found very quickly that they were giving out building permits to companies that didn't have business licenses, because it was 2 different departments, and they didn't communicate.
2 different operational systems, 2 different sets of data.
And these people probably worked 10 feet away from each other, but it was never visible until they started looking at the data.
That wasn't Missoula, by the way.
It wasn't Missoula. It wasn't in Montana. We went further, and they said, well, all of these great building permits that we're doing, great. So we just started drilling down. And that's the wonderful thing about using little data. Here are some of the examples of what we're working on, or beginning to work on the Missoula City budget, which we found to be a somewhat difficult entity to really get a handle on for past budgets, to see the real data, which is no fault. It's just that it's difficult. But the great thing about it is that you can look at a spreadsheet like this, but you'll notice, because this is a slide, it won't show. But in the real world, I would click over that, and the numbers would start showing up, and I could click onto that graph, and then I could drill down into the actual individual budget items. so you can start seeing things. It gives you layers of data that you can drill into.
So we do a lot of that too, because that helps people understand what it is they're looking at. So instead of just seeing the high level picture like that, people can drill in and see what is behind that. What does it mean? How is it calculated? They can see all the detail there, so they come to a cleaner understanding. And you know, as everybody in the organization is seeing the same thing, a common understanding of what things mean.
One of the big movements now is called open government. And this is where governments are actually beginning to show their data and show some measurements, show how things are going. Here's an example of the city of New York. They spent several $1,000,000 in several years on getting some basic data information up on the web. And I don't know if you can read this, but every single department in New York has about 50 or so different measurements of how well they are doing versus plan. This is all open to the public who can watch it as the data is updated. So they can see how well is you know, the department doing, say the road department doing in terms of filling potholes or, you know, resurfacing streets, whatever it may be. And this is a huge movement, and I think that we're going to see more and more of that. People need to see that information, and it makes for a much better civic relationship with the elected officials. You get to see exactly more what's going on. Now, I don't think that analysts are turkeys. But this goes to another interesting element of this. As companies are beginning to realize they can't manage the old way with spreadsheets and silos of information, they're having to start bringing on some really talented people. And I mentioned this to you the other day and several other people. My son is in this field, and we're beginning to see this. I think it's going to be difficult to get hired in the near future if you don't have some understanding and just the ability to actually use some basic levels of data analytics. And I don't care what field you're in. This touches every single field. I've asked people, try and find something in your business or your organization that isn't impacted by data or couldn't be better managed by data. And I offered a bottle of wine, and I still have the bottle of wine. So.
You can have it over the weekend, drink it.
Yeah, I'm definitely going to drink it for sure. But it's a growing field, and you know, you look at big data as possibly a career. Think about little data too. There's some great opportunities there, and I think the University of Montana is really starting to do some interesting things there. And yes, we did talk to the school about being able to bring together various elements of data sets or different systems or whatever. That's becoming a huge field for people to explore and get expert in. Luckily, Joe Garrett is an expert in that. So.
Yeah, so another thing that you know, we focus on, or you hear this week, I guess maybe, is about big data and how fast lots of information is flowing through whatever system you're talking about. IBM Streams is a great tool, and it's great that the university is diving in there. In our world, that's like secondary to us, because if people don't understand what things mean, if people don't understand what questions they want to ask, if the correct data can't be integrated together first to make sense, it doesn't matter how fast it is or how much of it there is. It's just not going to answer business questions. And so that's where we focus a lot of our time. You know, we just worked with a company yesterday that, as Russ was saying, that was just absolutely thrilled to see their data coming together in one place for the first time. Well, we're updating that information for them once a day, and they're absolutely thrilled. They can't even imagine it being any faster than that. And that's great, because that's all they need. That's, you know, they're in the business on a day-to-day basis. It's not like they're trying to monitor the jet engine that gives off a terabyte of data a day. They're just trying to monitor their customers and their sales and their salespeople and their HR activities and all of that. And once a day is fine for that. So So that's what we're focused on the little data.
Well, one good example of this is traditionally it's taken 2 people 4 days to do their payroll at this company.
Mm-hmm.
Now it's done by 1 person in half a day. And they're just getting started. This is an evolutionary thing as you move it into a company. It starts small, but it begins to build, and as more people use it and they find out more reasons and more ways to use it, it just becomes something that really changes the whole environment of a business. It's quite exciting. Any questions? I've run out of slides.
I think you mentioned something really important. If the little data is wrong or is not,
Yeah.
what's the point of having big data? Because even worse is having the wrong answer. I mean,
That's right. Yeah.
if you're going to have a question, you're going to have an answer, but that answer will be wrong.
That is correct, and it only takes 1 time of that for an end user, a CEO, a low-level manager, whoever it is, to just throw that system away. Say, I can't trust this. I'm back to my spreadsheets. Yeah.
Have any of you seen the Adobe Marketing Cloud latest ad?
The which?
Adobe Marketing Marketing Cloud? Yeah.
No.
It's an ad that is the people on the data side start like, whoa, our clicks are getting through the roof, and they call the CEO, and the CEO calls China, and China starts creating more encyclopedias.
Uh-huh.
You mind that, like the big books?
Right.
So everyone, and more sheeps and more everything. And on the other side is a kid with the iPad, a baby with the iPad, clicking on the banner.
There you go.
Yeah.
You gotta be careful with which data
Yeah.
information and what decisions you're making based on that data.
Yeah, exactly. So another key feature of how we go about things is working with the people that are, I guess you'd say, the owners of each piece of information. So they're the people that really understand the nuts and bolts of it behind the scenes, what they're doing on a daily basis. And it's those people that make the whole system work, because they can see that instantly and say, no, that's not right. Because they'll just know something's wrong with that
It's the
number.
same user, okay, it's 1,000 clicks, but
Yeah.
it's the same IP. I mean,
So then the answer is why. They know it up here, but the system doesn't know it. And so that's what we do a lot of, is translating that to that, so that the system has some of that key logic in it, so so they can kind of cut their risk down as an organization, you know, of losing a key employee, that kind of thing.
Yeah, you have the challenge also of having an employee who is the only person who knows how to do something. And as you build a data analytic system, it begins to lessen the challenges or the danger of having that person decide they want to leave. Do you want to nudge him?
No way, he's having a good dream there.
I knew I just couldn't do public speaking that well.
Actually, are you going to talk about this? Because I was curious to see this.
Well, we would.
Oh yeah, that's the live one there. You can drill
Well,
in.
just what you referred to before on the status
Yeah.
slide is that functionality I was interested in.
Yeah, the functionality is, oh, are you locked up there? No, you're not. You're just
Shouldn't
not
be.
clicking.
There it goes. It's
So you
just
just
taking
clicked
time.
into 2011, so this is MIssoula's budget.
You need to buy more fiber optic from him.
Yeah, right. So there's 2011 by budget item,
Blue is all funds budgeted,
Yeah.
and then red is all funds actual.
budgeted versus actual.
And
And then you can drill in through there
right.
to any one of those for more detail. And now
Well, this
each,
is not from the city, this is what you
This is
put it into
this
this
is
is their
from the
numbers.
city. These are the numbers from the
No,
city, but we entered them into a form that we could use.
Right.
so now there's each item with all sorts of, well, every fund that's associated with that item and dollar amounts, and then we put color on there for good and bad, how much variance is there between actual and budgeted. So you can see, did they guess right or not?
And once again, these are numbers that I input myself, so They may not be right.
Yeah, there's probably a few wrong in there, but probably not too many.
But it's the beginnings of what we hope will be a real opening up of the whole budget process in Missoula. So that if we had our way, anybody could go online on the Missoula Gov website and see this budget data and see what have we done in X department over the last 5 years. How did we budget for it, and what actually happened by the end of the year?
So did you get paid for doing this, or are you just hoping that they'll hire you to do it, or let's
No,
we just did that for fun, but you know, I think we're kind of making a point with them too here, is that, you know, I mean, look, as a citizen, I mean, there's intergovernmental or fines and forfeitures. This is the most detailed data we could even find. It's like, what the hell does that mean? I don't know. And so we'd like to be able to drill in there or categorize them differently at things that make sense to the public.
If given all of the data, we can drill down to the transaction level so that you can see every single transaction that happened in the city of Missoula for a year. But as you bring that all to the forefront, you begin to see, you know, how did we do versus the budget. What was the optimal thing is to have it live, so that whenever there is data entered into any spreadsheet or whatever system that is connected, it updates it so that you can see here on May 8th, you know, our budget is X, we're at X minus whatever, and so we're under budget or we're over budget or whatever it might be. And there again, you build those off of, say, the thermometers that say green, red, yellow. And it makes it very easy to see, wow, we better talk to that department, or why did that department change, or whatever.
Yeah, in this
happening.
case for Missoula, it's kind of painful here. First, that it just isn't available, but second, you know, go back to the dashboard there, Russ. The data here, when we're looking at budget versus actual, we're looking at 2012 as the most current data there is. It's like, that's ridiculous.
Yeah, that's one of the things about little data. You can start making it live.
Yeah.
You can start, you don't have to.
In this case, that would make a big difference. If you could say, yeah, we don't have to look a year back, or a year and a half back, 2 years back now. Now we can look back to today, to tomorrow, or yesterday, or maybe a month, and make some decisions that are more timely.
So you've obviously got a lot of data summarized, and you can drill down and see the individual pieces.
Yeah.
Is there an ability to easily compare, let's say, you know, some activity over time here and another activity over time there, and then you can cross-plot them and look at the shape of the relationship between the data, having taken away the time element or something like that?
That's the beauty of the new technology that we have here. It's very easy after you've had some training to build these types of dashboards. And then you can take any data element that you have available to you. And so, you know, you can compare it and figure out, you know, if this happens and this happens and this happens, we put it together and we look at a graph and we say, ah, there's a relationship here. There's something. And it's an example is hospitals are all trying to figure out how to lower the readmittance rate, which is a big cost. You have somebody in the hospital for 3 months, they're fine, you can go, and a month later they're back at the hospital. So what happened? So they've been really working at grabbing all kinds of data from everywhere. The more data you can get, the better chance you're going to see some relationship or some causality to some impact. And they've worked this over and over for years now. And they figured out that one of the most impactful things on whether you were going to be readmitted to a hospital was whether you had someone at home that you had to take care of. And so now hospitals are starting to put in programs that if you are going to be released, you know, discharged, they can work up programs so that some of that pressure of you taking care of, say, an elderly patient, a parent, or a child with challenges, whatever, maybe they can start providing some services so that it doesn't, you don't have the full load. And the chances of you having to go back into the hospital because of whatever are limited, are lowered. So it's finding those different relationships that are,
yeah, so time or dates or a month usually, oftentimes maybe a year, time is a good way to relate non-relational data, you know?
Yeah, right.
So things that just don't match, you can still do on time, put them together, see if there's a trend, see if the one goes up and the other goes down, whatever it is. So yeah, it's fun to do.
But it's when you take the data, this isn't everything. You have to use your experience and your understanding and it's your innate knowledge that you have about a particular subject. I was listening to a researcher who runs a very large data analysis company, and they were working with a grocery chain. And this chain was looking at sales of various products. And the chart was just like this. There was just no relationship. There wasn't anything you could tell. And he said that his group of research scientists spent 2 or 3 weeks trying to figure out why was this product having these huge swings. And I was sitting in a class with a lot of university students, various backgrounds and all that. And when they put the chart up there and asked the question, one of the students, in about 3 seconds, now remind you, it took his PhDs several weeks, said, it's welfare checks. It's when people got paid, they would go to the store and buy this particular commodity. And then they weren't going to buy it again until there was a next check. So it's that innate knowledge that you have to add into the data that you see. You know, why, the data says that, why was it, oh, I know why. It's because we did that week or something, whatever it might be.
Well, plus a sort of ability to turn it from a time history into a frequency versus magnitude
Sure.
thing, where you see a big spike that's on an interval, and you can say, well, what's causing that interval? And you know, it's being able to transform it into different domains is really useful.
Yeah, it does change the way a business or an organization runs. It's changing the way government is run. It's changing the way school systems are run now. You see performance measurements now for universities. You know, how can we measure what, you know, are we recruiting, you know, the right students? Are we providing the education for them so that they can graduate in 5 years? And are we helping them find those jobs after school? And there's ways to measure if you're effective at this. And you can measure it, that's fine. The real key is, can you proactively manage it? Can you have that data available very, very quickly so that you can say, you know, this is a first person in the family who's going to college. The chances of that person moving forward, there's some risk there. You know, there might be some other risks there. And you start looking at those risks and you start putting together the history, and it says that if this student with this background starts getting these grades in these classes, the chances of them dropping out of school are 90%. So you go and target and try and figure out ways to help them, to try and not have them drop out. As it would be now, I mean, grades came out, kid's gone. You know, this way you can be more.
They're doing that.
Yeah.
Student success. We got a whole department in that. That's what they do.
Uh-huh.
They look, you know, to start with, they're looking back to see why it happened.
Mm-hmm.
And then they try to be proactive and get it before it happens.
And so how are they getting the data on the students?
Well, they've got a sample.
Uh-huh.
They'll pick certain students.
Yeah.
Just keep track. Well, the ones that don't complete, they go back and try to explain why they don't complete.
Right. Right.
And then when they decide what variables are necessary to spot that, and then they try to use the same variables on all students to try to predict it ahead of time.
So how are they analyzing that data, though?
I don't know.
Yeah.
Probably spreadsheet. Is this your software that
Yeah.
we're seeing?
Yeah.
How do you get the data in the first place if it comes from all these silos?
It's a lot of magic. It is a whole profession, and it is a highly complex. This gentleman has been doing this for, what, 15, 20 years now, and has worked with some of the biggest companies in the world who had, you know, 4-year programs of implementing business intelligence, and they were spending $30–40 million, and they got to a point where it either wasn't working or nobody would use it. And
Because they didn't believe it.
because they didn't believe the data.
Yeah.
And so the art of being able to bring data from a whole lot of places together and then be able to convey it and communicate it to the users in such a way that they can begin to see, no, that's wrong, that needs to be fixed, or this is right, I understand that, or this is how we handle this type of a transaction. That's the whole basis of it.
But there are great tools out there for doing that. There's lots of them, actually.
For collecting the data?
Yeah.
Right.
Yeah, but
We've
it's,
also actually offered this to the university to offer to all students to use, so we'll see if that goes anywhere.
Suppose that each and every one of the silos had good spreadsheets and so on.
mm-hmm.
Can those then be imported pretty easily into your
As often as
dashboard?
as often as the organization wants to have them updated into the system, and it can be every hour.
Yeah, it could be data from spreadsheets, could be data from databases, could be data from their operational systems, from external websites, pretty much anywhere. Except PDF files.
Yeah, PDF files don't work.
Those are no-nos.
What we really love is to be able to provide a sentiment meter. And so we'll go out and gather all the tweets that are being made about this particular organization. And you can start seeing sentiment change. Are people saying good things about us? Are they saying bad things about us?
So you talked to Alex about that? They got a mood meter on a project they're doing.
Oh,
There's lots of people working on that one.
yeah, it's,
You weren't here yesterday?
That's what Alex
Where
was
you
doing. I
get
think he was correlating it with.
no, I was busy out with the client.
But they were, but they were assessing mood.
Yeah, very
On
important.
a 3-point scale.
Yeah, yeah.
but From tweets.
Yeah, it's something. It's a lot of fun. But yeah, any data, but not any. I don't think you've run into much that we haven't been able to do, huh?
Usually you can come up with something.
But yeah, and say it's and you also have to think about with Sherry Davidoff talking about security. You've got all these unsecure spreadsheets sitting out there on computers all over the place. You know, is that the best way to have your, the real?
So is your system storing the data again? In other words, is it being imported, and so now we've got spreadsheets and your system database?
We can do lots of different ways. That's one of them. So if that actually is quite effective, because for decision making, you don't need every piece of data. You need important pieces of data. And they happen to exist all over the place. And so to bring just the important pieces of information together for decision making is a pretty powerful tool to be able to do and centralize that. Oftentimes that makes the spreadsheets obsolete.
And my question was,
So they just don't need them.
do the spreadsheet, whatever, the source still exists? And then you have, so is there redundant storage in effect here? You've got the same data?
There sometimes
different
is and
form.
sometimes isn't. So we can query directly into the operational systems if we want to do that.
Okay.
And we can tie systems together that way, or we can capture some of that data and make a copy of it, integrate it, slice and dice it different ways, and store it again. Yes, we can do either way.
And just to give you an example of how far the technology has moved, when we work with an organization, the organization doesn't have to buy any software, doesn't have to buy any hardware, and doesn't have to go out and hire very expensive analysts. We just provide them the ability to start answering their questions. So the technology is changing very, very rapidly here.
Yeah, it is. And then, of course, like Russ showed you the dashboard there, I mean, that's all available just via browser. So phone, tablet, browser, doesn't matter. It's a security thing there too, because that data resides while you're looking at it, but as soon as you close down that application, it's gone. So you don't have to store your data on your laptop. That could get stolen and that kind of thing.
Joe loves to ski. And throughout the United States, you have what are called snowtel sites that take hourly readings of snowfall all through the mountains. So he figured out he could grab the data from each of those snowtel sites every hour and then triangulate it with the local ski resort. So he knows better.
The best powder is ever all time.
Do you think that'd be a good idea? How
yeah.
about if you said, okay, in order to go to Snow Bowl, I need to get up by 6 o'clock so that I can get dressed and get on the road and get up there, so I'm on the first lift. So at 5:55, if you said, if from last night, from when to when can it be set? You can, from whatever you want.
Well, yeah, so we have it set, it's hourly readings, so we say, I want to know about it if snow has fallen from 4 p.m. till 9 a.m. the next morning, because that hasn't been skied on yet. So if, and then I set my threshold, if that's over 8 inches or whatever, give me a text message, give me an email, whatever.
You'll get a text alert.
Hot-foot at the red lodge right away,
Yeah.
because that's where the best powder is.
Yeah, exactly.
Because I'm sorry, but ski resorts sometimes don't tell you the truth.
Yeah, we got 2 feet. We got 2 feet yesterday.
Yeah.
Say, no,
So-
you got 4 inches.
Start your coffee if
Yeah.
if the conditions are good.
For an additional
good.
fee, we can get it to start your coffee maker. But what we do is we offer this to companies, CEOs, and we charge them a lot of money with the understanding that we won't give it to all their employees. So that they're not going to be calling in sick all of a sudden because the powder is out there. And that's just kind of an idea, and just an answer. I mean, that's some of big data, but it's how you can really practically use it. It's a lot of fun. I think that's the one thing that I get out of this, is that when you start getting into the data and start freeing it up for people, it is so much fun. It's a lot better than spreadsheets. Anyone else? Thank you. That's us. We're part of big data here in Missoula, and we're having a ball.
Well, hello again, everyone. My name is Eric Franzon. I work in the arena of the semantic web. Just out of curiosity, who here has heard of the semantic web before? All right, we have one. We've got a ringer. 2. All right. Fantastic. So I am president of semanticweb.com. Semantic Web is not a product. Nobody owns it. Semanticweb.com is a site that talks about news of business applications of semantic web technologies and semantic technologies in general. So what is this stuff all about? Well, that's what I'm going to tell you tonight. And I'm really glad that Russ and Joe were able to present, because a lot of the things that they were talking about, data silos, focusing on small data, are going to play into my presentation here. So how many of you have heard the word semantic before? Well, in semantic web, it means the same thing it means in linguistics or philosophy. It means meaning. So semantic web is about finding the meaning in the data. And all this week we've been talking about big data, and we've been looking at it from a pretty high level. And so we've been looking at big systems and big patterns and big chunks of data. And here we're going to get a little more granular, because it's at the granular level that we as humans can really start to understand what we're looking at. And it's also the point at where machines can start to interpret the data. Semantic web is like the harmonica. Not exactly, but I'm not big on sports metaphors, and so and I am big on harmonica. So that's my metaphor for this evening. Bear with me. How is it like the harmonica? Well, it's easy to play. My little boy can pick this thing up, breathe in and out of it, and get instant gratification. He can get a response. And semantic web technologies are very similar. You can do just a little bit and do some pretty cool stuff with it. That said, this same little instrument, this same little piece of plastic and metal that makes this kind of sound, is the exact same instrument that's used to make this kind of sound. And semantic web can be used and is being used today to drive business critical systems worldwide. Huge amounts of data flowing in and out from household names that you've heard of. Your financial data may be going through some systems that are using semantic web technologies. Experian, one of the big credit reporting agencies, acquired a company out of the UK a couple of years ago called Garlic. Their whole database is built on semantic web technologies. So what we're going to talk about tonight is what is semantic web, what are the core technologies of it, and who's using it and why. First of all, to dispel some myths, because there are a lot of myths about the semantic web. It's not a software package. You can't walk into Best Buy and pluck it off the shelf and put down your money and buy it. It's not something that will ever be done. There's a lot of noise out there about, oh, the semantic web failed, it never happened. Well, the web itself will never be done. It's an ongoing system. People are constantly adding data to it, changing the data. The technologies are improving over time. Semantic web technologies are in use today. It's not a replacement for the current web. It's not a pipe dream. As I said, it's being used today. It's also not a silver bullet. A lot of times people start understanding it and they say, oh, this is fantastic. I can use it for this and that and that. It's not going to fix all your problems. Data quality, it's not going to fix data quality. Garbage in, garbage out still applies. It can help in surfacing some data quality issues, making them easier to spot, which can be very helpful. It's also not HAL 9000. Sometimes people start looking at this and they start getting scared and thinking, uh-oh, this is Skynet, this is HAL 9000, this is big, scary, big brother stuff. It's not necessarily that either. Not yet, anyway. So what is it? It's a web-scale architecture. It's based on the same core principles that the web itself is built on. So when people ask, does it scale? My answer is, well, does the web itself scale? Yes. It's a metadata technology. That's a word that I've heard a couple other times this week, but for those who may be new to that term, it just means data about data. It's data that describes other data. And you can think about it, instead of a replacement of the current web, think about it as a layer of meaning on the existing web. And as I've said, it's in use today. It's based on standards out of the World Wide Web Consortium, also known as W3C, the same people that gave us HTTP and HTML. So when we type an address into our address bar and it has that little HTTP in front of it, that's because of the World Wide Web Consortium. They created the standards that all the browser companies use and that get folded into products by Adobe and other vendors out there. When the web first came about, it was so exciting because suddenly we could share information globally, inexpensively, and in real time. And that was huge. And in fact, it was so huge that corporations and organizations jumped a hold of that. And they not only used it on the public World Wide Web, but they started using it behind the firewall, privately. That's when we saw intranets and portals coming about, because they said, we can use this and protect data behind these other security measures. Semantic web is very similar. There are a core set of standards out of the W3C. We have 3 of them here. These are probably the 3 biggest ones, RDF, OWL, and Sparkle. We're not even going to talk about OWL tonight. It's more complex technology. It's a very interesting one and a powerful one. If you really get jazzed about this stuff, I encourage you to look into it. But we're going to talk about RDF and Sparkle particularly because they're very powerful in that they help us share data globally, inexpensively, and in real time on the public web or behind the firewall or in combination. These technologies are used to connect data on the public web, behind the firewall, or in combination, and to make it interpretable by machines. A lot of people talk about machine understanding. I prefer the word interpretable because in my mind, if a machine can interpret the meaning of a bit of data, then it can calculate that. It can work with that in a way that the machine is used to operating. So let's take a look at machine interpretation as the web has evolved. And what do I mean by machine interpretation? I hate the idea of versioning the web, but I'm going to do it here anyway, just for the purposes of this. If you think back to those early mid-1990s days when people really started becoming aware of this thing called the web, and everybody was saying, oh, I have to get a web page. It was all about linking documents. That information that companies and people were sharing globally and inexpensively and in real time was in the form of documents, HTML documents and PDF documents, and it was just sharing and linking those documents with those little blue links that popped up everywhere. Back in those days, here's a typical Amazon web page. You know, you and I can look at this and we can see exactly what this page is all about. A lot of information on this kind of a page. This is a piece of music. However, my machine is really dumb about this information. My machine understands, okay, characters and formatting and images. I know I need to render an image right here, and maybe it's a GIF, maybe it's a JPEG, I don't know, but I need to render it. And I know that this text needs to be bold and this text needs to be blue, but it doesn't have any idea what this page is about. Web 2.0 has been this wave that's been all about linking people, our likes, our dislikes, our social networks, our interests. We added a ton of data into this system of the web with these Web 2.0 technologies because suddenly I, as a user, could add information, data, to this system, to a web page that I had no part in programming. I could go in and review this piece of music, and in fact, we could create data about that data. We could create metadata. Was this review helpful to you? Yes or no? Another user can come along and add a layer of data on top of my data. So we suddenly started throwing tons more data into this system, but unfortunately, my computer is still really dumb. It has no way of understanding what's going on here. It's still just characters and formatting to them. It's really hard, not just for our machines, but for us to understand what's going on if we don't have the proper context for something. And semantic web is all about context. So Web 3.0, or the semantic web, is about linking data. If we're able to tell the computer specifically that this image is a representation of a cover, an album cover, and we can say that there's a band associated with this piece of music, and this collection of music has a title, and the songs have titles, and there's a format. In this case, it's audio CD, but there's MP3 music available. There's a price associated with it. That's interesting because Amazon has Amazon.com, but they also have Amazon.co.uk. So there's probably a relationship between this price and the price in pounds sterling for the same piece of music over at the other site. And between those two commodities, now my computer can start to get some smarts, can start to understand what's going on here and do some computing on it. And that's why we use computers, to do the computing so we don't have to make things happen faster for us. For those of you computer scientists in the room, you may find this particularly interesting. For those of you who are not, bear with me and follow along as you can. Back in the day, the first computers that we used were siloed. Thank you for introducing that word. They stood on their own, and we had to use that computer and all the information inside that computer to compute. And there was no sharing between them. And then TCP/IP and DNS were introduced, and then we could start to connect our computers. Physical location was not as important, but the documents and media inside those computers were still siloed. They were separate. There was no sharing of information between them. So then we created HTTP and HTML. That was when we could start sharing all those documents and linking them together. However, the data, the entities, and the concepts inside those documents were still locked in there. If you did a search on Google for some concept and it happened to be mentioned in a 30-page PDF, it would link to that PDF, but it was on you to search through it to find that concept that you were looking for. So with the semantic web standards that we're going to be talking about tonight, we're just at the next level of abstraction. We're breaking those entities and concepts out so that they can be linked together. And there's a lot of power that comes with that. So the standard that the W3C has for doing that is something called the Resource Description Framework, or RDF. It's just a way of modeling data. It's a data model. It's a way of saying that the data in this system is going to be represented in this formal way. My friend Dean Alamang had this wonderful quote describing what it's good for. RDF is good for distributing data across the web and pretending it's in one place. You can start linking it together. So it's used to connect data and to make it interpretable by machines. And RDF is made up of something called triples. So that's what we're going to talk about next. Any questions at this point? Okay, I'm going to keep throwing information at you. So how do we make things interpretable? By uniquely identifying things, by uniquely identifying relationships, and by using triples. So what's a thing? What do I mean by that? Well, a thing is anything that can be uniquely identified by a URI or a literal. So what's a URI? Remember that thing you type into your browser bar? You probably know it as a URL. URI is a more general term that includes URLs, but is not limited to URLs. Instead of just saying, I'm going to point to that document or that thing on the web, a URI is, the I is for identifier. So you can identify something within the web. It doesn't have to be a full document. It could be a piece of a document or a piece of data in a document. Just know that if you put one of those HTTP things on it, you can identify a piece of data. That's the key concept here. Or a literal, a string of characters. These are all things that can be identified in one of those ways. I can be identified by a URI, my postal code, the location of the White House. Here it's represented in long codes. LA County's sales tax rate, because we don't have one here. Even a photo or some other piece of media. They can all be addressed with a URI. This is a collection of things. People who have worked with relational databases are used to seeing things in this format. People who have used Excel are used to seeing things in this format. The real power comes in identifying the relationships between the things. So this is my who's your daddy example. I can tell you that the person in this photo is the father of the person in that photo. What's interesting is I can also represent that programmatically. I can address that photo with a URI, and I can say that the thing represented there is the father of the thing represented there, and I'm not going to put a URI in there just because I like looking at her picture. She's a lot prettier than I am. Where the real power comes in is I can actually programmatically, and don't worry about understanding the code here, just know there's a way of formally representing that relationship, of saying the person here is the father of this person. And it may be that I want to use, and by the way, I didn't write this. I got this piece of code from a vocabulary that's already out there describing relationships. And I can pick and choose in Semantic Web which vocabulary I use. So in this case, I may decide to use a vocabulary that talks about this relationship from the Mayo Clinic, because I'm the biological father of this person, and I choose not to use a vocabulary that comes out of an adoption agency or a computer science museum that says that Tim Berners-Lee is the father of the World Wide Web, because those have different meanings than the one I want for my data set. So I, as the application programmer, can decide at that level what vocabulary I want to use to describe that relationship. It's very extensible. So I can then go in and very easily just add another node, another piece of information, another data point on my graph, and say the relationship here is the same to that thing. That's where the data model piece comes in. Spoiler alert, so apologies if I'm ruining anything for anybody here, but someone else can come along and go and find that vocabulary out online and use that vocabulary for their data set. It's just out there. I'm sorry. I really, yeah. Okay, so let's take a look at these triples. What is a triple? Well, that's my little triple guy, so when you see him, you know we'll be talking about triples. It's very basic. How many of you remember seeing this kind of diagram back in school?
They ought to be teaching it still.
Yes, they ought to. So this is basically the structure of a triple, except it's even easier to understand triples because you're just saying there's a thing here and a thing there and a relationship between them. Or, in a more formal English teacher way, there's a subject, a predicate, and an object. And in fact, subject, predicate, object is the exact structure that semantic web technicians use. SPO, subject, predicate, object. That's a triple. So as a result, these are all things that can be represented using triples. All of these statements could be programmatically represented in that same format. So drawn as a graph, you can see how some of these start appearing, and you can start to make assertions with these kind of things, with your subjects, objects, and predicates. You can make statements and assertions that a computer can understand, can interpret. Here's a simple graph, some information about a song. You can see that relationships can go in two directions, depending on the vocabulary you're using and the information that you as a programmer want to convey. The trouble with triples, I'm sorry, I have to, I'm enough of a geek, I have to make the joke, is that they multiply. And you can only imagine if you start making these statements, you're going to get a lot of them. So what do you do with them? This is an actual graph of triples from the pharma space. I don't begin to understand it, but people who work in big pharma absolutely do, and they love navigating data in this way because they can drill down and go through and find specific categories of drugs. They can find relationships between drugs and work in drug discovery. So where do you store them? Well, in a triple store. A triple store is just a native semantic web database. But that's not the only place. There are proprietary triple stores, there are open source ones, but you can also store triples in relational databases or as a native file, a text file. They can be added into existing documents, HTML documents. They can even be generated on the fly, to the point that, that Joe was making earlier about needing the flexibility that sometimes you need to keep the data and sometimes you don't. Sometimes you just need to generate it, compute on it, and let it go. So for those who are interested, there are a lot of different syntaxes for writing RDF. They all have pros and cons, but they're all about this same concept. Identifying things, identifying relationships in that formal way. Okay. Questions at this point? All right. Relational databases have been around for a very long time because they have this formal way of representing data. They have a robust query language. Has anybody here ever worked with something called SQL? Okay. Semantic web also has a robust query language, and that's what we're going to take a look at now. It's the Sparkle Protocol and RDF query language. It allows us to pull values from structured and semi-structured data. Structured data is just data that is in a formal structure like a relational database. Semi-structured data might be something more like XML or something that has some structure around it, but it's a little looser. You have some more flexibility. It allows us to explore data by querying unknown relationships. We don't need to know up front what the relationship is between different data points. In fact, we don't need to know the structure of the data up front, and that's a really important point that we'll see in a little bit. For those who care about doing joins between databases, it allows you to perform complex joins between disparate databases through a single query. And you can transform RDF data from one vocabulary to another. So if you have two data sets and they're using different vocabularies, you can tie them together. Okay. So let's pretend that we have a database. It has some data about people. We'll say this is Eric there. And Eric has a depiction. That depiction has a license. Anybody here familiar with Creative Commons? Okay, good. Creative Commons is an open licensing platform. You can go online to creativecommons.org, type in the requirements you have for something, and come away with a license that is legally viable. You'll see all the slides in this deck have a little icon at the bottom, except this one because the image covered it up. But it's a Creative Commons license. It just says that people can reuse the images, but they have to give attribution back to me, can't be used commercially. There are all kinds of restrictions you can put on it. Creative Commons is awesome. I encourage you to take a look. So that image has a license. Eric likes blues. Eric also likes blues, which is a club in Chicago. Recently, my wife and I bought a house here in Missoula, and we were renovating it, and lo and behold, I discovered that I really like blues. So you can start to see there's a data problem emerging here of disambiguation, where you have to start telling the computer, no, I mean this blues, not that blues. There's another database out there in the world. Bob wrote an article. And that article is about a place. Well, what if we could draw a connection? You know, this guy used to live in that place. And that has a license as well. And in fact, it happens to be the same license as that one. So what could we ask of a system like that? You know, all this disparate data, you have Creative Commons licenses and the definitions in one place, database over here with information about people, something else over here about articles. Well, let's see, we could ask, what does Eric like? Get some information. What has a Creative Commons license? Show me all the things from these databases that have that license. What license does this document have, or that document? Or what about what is liked by anyone who has lived somewhere that is the subject of a document Bob has written? You could start doing some pretty cool queries with this kind of modeling and with Sparkle. So I mentioned that a lot of companies are using this to do what's very important in the executive suite. And that is make money, save money, mitigate risk, and solve real-world problems. So I want to talk you through a few of those examples. Here are some industries where it's being used: healthcare, life sciences, financial services, manufacturing and retail, marketing and advertising, SEO and SEM, search engine optimization and marketing. Libraries, archives, and museums are using them. Governments, a lot of the open government data that Russ referred to earlier is in this format or available in this format. So it makes it that much easier to tie into. And more industries are using it. It's growing all the time.
Social.
What's that?
Social media is, Facebook is pretty much everything you just mentioned.
Facebook announced, I want to say it was about 5 years ago, their use of something called Open Graph Protocol.
It's like two years now.
Yeah.
The Open Graph?
Yeah.
Yeah, exactly.
And
Finding pages that Derek liked.
that's right. And it's based on RDF, the Open Graph Protocol. is based on RDF. So the reason that Facebook is able to tie all those things together is because they're using these technologies. Best Buy is using them to great effect. There's a gentleman at Best Buy by the name of Jay Myers. And Jay was really frustrated because he was driving around with his wife and he was trying to find a refrigerator. And he works at Best Buy Corporate, and he couldn't find a store that had a refrigerator with the specs he wanted. In fact, he couldn't even search on the specs that he wanted. He knew he needed it to be a certain size, they wanted a certain color, he needed it to be delivered, he needed it soon, so they had to have it in stock. He couldn't find that information. So he started doing searches, and in fact, he was shocked to find that when he searched for Best Buy Minnesota, which is where he lives, or Best Buy Minneapolis rather, that wasn't even the first listing that came up at the top of the search results. So he couldn't find the address. He had to drill down. It was incredibly frustrating. He started implementing semantic web technologies in their website. And he started by putting in some really basic information. What's the address of this store? What's the phone number? How do you contact it? What's the lat long code? I don't know if you can see up here, but he coded in the geolocation. A lot of really interesting information here, the opening and closing hours. And what he found was suddenly when you asked a search engine, Google, Best Buy Minnesota, it used this information to not only surface a link to that website for the store, but it surfaced, hey, here are the hours of operation, here's the phone number, here's all the information that you need about that store. So Jay was pretty happy about that. That was a nice experiment for him. So then he said, okay, what if we mark up all 600,000 plus items in the Best Buy product catalog? He's a data geek, he gets into that kind of stuff, and so he did. And they've been able to solve some really cool business problems with that. Fortunately, they had a good tale to tell to the business unit within a few months. This was back in 2009, by the way. And Jay reported at that time a 30% increase in traffic on those pages that had RDF inside them, and a 15% increase in the click-through rate through Yahoo. So that was enough for the people holding the purse strings to say, keep doing what you're doing, Jay, that's just fine. And that gave him the leeway to experiment and keep doing some cool things. He solved the open box problem, which is one that's been plaguing the retail industry for a long time. That's the one where you go to the store and you buy the big TV and you bring it home and you open up the box and you realize it's too big for the wall. So you put it back in the box and you take it back to the store and they take it back, but then they have an open box that they have to sell. So they put a big ugly orange sticker on it and they try to sell it. They didn't have a way, in fact, no retailer had a way to let customers know that that was available, perhaps at a good deal. And they want to move that product off the shelf quickly so they can have new product back in the store and on the shelf. So he used that product information he had marked up to tie it into an app that was based on WordPress, so a store manager could open up a website, even on a tablet, and say, I've just received an open box item, it's this specific product, here's the price that I as the store manager want to put on it, and the specs about it, maybe there's a dented box, or maybe it's missing a cord, or whatever it is, or maybe it's in pristine condition. And the store manager could instantly click a button, that information gets added to the store's website. So today, if you search at a Best Buy website, you can see what open boxes they have in store for you to go buy. BBC is using semantic web technologies. They had another big business problem. BBC is the largest broadcasting corporation in the world. 8 national TV channels, 10 national radio stations, 40 local radio stations, an extensive website. They have BBC America. They have a lot of stuff that they're putting out every day. Their business problem was that they had 1,000 to 1,500 programs per day, and they wanted a website for each and every one of them. A unique website generated for each one of those unique programs. In order to create that, they needed to relate information from all of their holdings and allow editors to bring it together to quickly generate these websites. So they set about doing that. They said, okay, we are going to create a web presence for each and every one of these things. And they created something called BBC Programs. They spell it funny, but And I increased this so you could see what it says. So it aims to ensure that every TV and radio program the BBC broadcasts has a permanent, findable web presence. So everything that they have produced has that, and it stays in their catalog. Good shows like this. And there's a lot of information that's on here that is not necessarily coming from a BBC database. That's the other key thing I want you to take away from this. They're tying into other data sources on the web. They created unique identifiers for each and everything they produced using those HTTP URIs. And that allows them to tie these properties together. This is an example of their iPlayer radio, and BBC does a lot with music. So what they did to get information into this system, by way of example, is they tied into something called Music Brains and Wikipedia data. Music Brains is a data set that's basically the data you see when you put a CD into your computer, and it pulls up the tracks and the length of the tracks and all that. And Wikipedia, hopefully you all know too, there is a semantic representation of Wikipedia called DBpedia, Databasepedia, and it's just information from the little info boxes that appear kind of in the upper right of a Wikipedia page that have been sucked out and turned into those semantic triples. So BBC had another business problem here where they said, we're a news agency, and so what we say has some weight, and we have to be careful about where we're pulling data from. So their answer to that was they became curators of Music Brains and Wikipedia. Their editors contribute to those systems in a really virtuous circle that makes that data better. They also do it for their wildlife. And they have an amazing, amazing amount of data on wildlife. And they're pulling it from other places. And I pulled this up just so I could show you, they have most popular video clips. Well, most popular, they're obviously doing some big data analysis to figure out what is most popular there. There's not an editor for each and every web page who's sitting there constantly checking stats to see what's most popular. They have to rely on algorithms to do a lot of that. They have elsewhere on the web. They're pulling in video collections and habitats and information on behaviors. They're pulling this from WWF's Wildfinder. They're pulling in information from all over the web and putting it into BBC websites dynamically. LOD in this case, I just wanted to introduce as a concept, is linked open data. It's data that's available out on the web, and it's linked using these URIs. So this was the approach they took, and it's pretty cool to see what they've done with it. They also opened it up to outside developers to be able to reuse this data that they've created and build their own apps. Okay. The fire department in Amsterdam in the Netherlands is using this stuff to help first responders get to incidents faster, which I think is so cool. This gentleman right here is a firefighter, but he also happens to be a founder of a software company. His name is Bart van Leeuwen, and he's big on semantic technologies, and he did this out of fear. He had a real problem. He works in an old city, an old European city. And the challenges of a fire truck and navigating a fire truck are very different than those that you and I have. They can't use traditional GPS devices. They can't use them because in a city like Amsterdam, there are a lot of old cobblestone streets that are very narrow, far too narrow for a fire truck to go down. They can't use them because fire trucks don't have to obey the rules of the road that you and I do. If they need to go the wrong way down a one-way street, they absolutely can, and they need to know that that's an option for them. So he looked at this problem and he said, you know what? The firefighters in our department know this city. They know this city very well. They live here. They've lived here for years. What we need to know is other pieces of data. We need to know, where is the incident? Where is our firehouse? So that we can visualize what's the fastest route from here to there. That alone was a huge advancement for them. This is the kind of GPS base they needed. Now they're able to tie in other additional information. For example, they can tie into a municipal database that tells them there's construction going on right here in real time. They can see that this incident that they're going to is the Anne Frank House. There's a lot of information about the Anne Frank House. The Anne Frank House is a museum. It's a historical site. It's also an office space. And it's a residence. There's someone who lives at the back, one of the curators. So all of that information is critical for first responders to know in getting to this incident, but it's all in these different silos. All that municipal data and everything else. So he is tying it together using semantic web technologies. It's not just big organizations like Best Buy and things like that. There's a little nail salon in West Hollywood, California. Just so happens this one is co-owned by my wife, and that's why it has semantic web technology inside of it. And I originally did this because I was giving presentations and I was talking about Best Buy. And I would talk about Best Buy and there'd be two reactions in the audience. Oh, Best Buy, that's great. You know, the real player is using it. But Best Buy has a lot of money. They have a deep technical bench. This must be hard. It must be expensive. So I sat down and carved out 4 hours on a Sunday afternoon and said, well, I'm going to do what Best Buy did. And I'm going to put hours of operation and lat-long codes and phone number and that kind of information into our business website. It took about 20 minutes. Keep in mind, I had never written this kind of programming before. I had studied it, I had talked about it, I had talked to the developers who were doing it, but this was my first attempt at it. This was back in 2010. And within 2 days, we were indexed by Google. This was back when that didn't happen. You had to wait a while to be indexed by Google, especially a small site like ours. And suddenly, we started seeing all this rich data show up because we were talking about that data. We were telling the computer, this is what you will find there. The other thing that was really powerful for me as a small business owner, and kind of the reason that I tell small business owners they should be looking at this, after I did all this work, I tweeted about it. And within a half hour of doing so, someone I know who works in semantic web back east sent me this photo. It's a screenshot from OpenStreetMaps, and it has a call out on it with information about the business. It's not all that pretty, but that data is in there, and I didn't have to do anything at all to build this. So the next time that someone comes along and builds an application for busy mothers in West Hollywood who are looking to go get their nails done, the data's there for them. They could just pull it right up in that app, visualize it however they want, put pretty pictures around it, say, so that when that mother is out there and she looks down and sees that baby is asleep and she has 30 minutes to go take care of herself, she can go do it finding our shop using that app. That's value for a business owner, because I did that 4 years ago and it's still up there. Okay, questions at this point? I'm going a little past 6 o'clock and I apologize. If anybody needs to leave, I will not be offended. Yes, sir.
What's the difference between your store hours, the way you wrote it, and just the normal HTML?
The key difference is that right down here, the store hours are listed. Those are human readable. But a machine can't look at that and understand what I've said there. With putting the code in there, a machine can point at that and say, ah, I see. He's specified that these are store hours, that there is a concept out there called open time and close time.
Is that hidden code or?
It's not hidden, it's an attribute around, it's just in the HTML. It's another attribute around the text.
You don't see it, but the code is there.
That's right.
How does it take to read it? Can any browser read it? Or?
Browsers, it won't affect browsers, it won't hurt browsers. They're basic attribute value pairs.
Yeah, they don't understand those relationships.
The browsers are getting better about it, but the search engines are the ones who are really consuming this data.
So that's why on the previous slide, though, when you have your search results, it doesn't just present a minimal, like it presented the
Simple
hours
blue
right there,
link. Right. That's right.
Whereas yeah.
Yep.
Yeah, Eric, I see, for example, I see that you have your address, and I mean, so Google is recognizing because you put it in a W3C RDF format, right? Is that correct?
That's correct.
Because, for example, if I put davidnassif.com and my father is Antonio Nassif, I mean, that's not something, I mean, I have to stick
That's right.
to W3C RDF format, and in that way Google will index it. Like
There are several syntaxes where you can write triples. Within an existing web page, you're looking mostly at RDFA or microdata. And I'll talk about that in just a second.
So are those the vocabularies you mentioned?
Those are the syntaxes. The vocabularies,
So Google, though, must be paying attention to a certain vocabulary that you had.
I'm so glad you said that, because who's using SimWeb? Google, Yahoo, Bing, and Yandex. Yandex is the largest search engine in Russia. These three got together about 3 years ago in 2011 and agreed on something. I'm going to let that just settle in for a minute. They agreed to work together on something. And for about 9 months behind closed doors, they worked on something called schema.org. Schema.org is that vocabulary. They agreed on a vocabulary. Now, we talked a bit about the Open Graph protocol that Facebook had come up with. That was about a year before this came out. Speculate, if you will, about whether there's a cause and effect there. I think maybe some people here thought that Open Graph protocol was great, but it had the wrong owners. So they came up with schema.org. Schema.org is a collection of schemas, or just HTML tags, that webmasters can use to mark up their pages in ways recognized by major search providers. So they agreed, we're going to have this central place, schema.org, where we have agreement about what we're going to call things. And because we're competitors, we're not going to tell each other or anybody else what we're doing with that data, but we're going to tell webmasters that we're looking for it. And that's exactly what has happened. So if you go to schema.org, you'll see pages like this. This one describes a type of thing that is a product. And there are all kinds of properties about a product. You can say that it has an additional type for the item, a description of it, an image representing it, that it is the same as something else. So you could say, this product that's in our catalog at Best Buy is the same as this item described on a Wikipedia page, or on the manufacturer's webpage, or, and.
So those are the predicates that list there in 11.
Yes, that's right. These are some more organizations that are using Semantic Web to do different and really interesting things. I'll let you just kind of look through. This one over here is kind of interesting, GS1. They're the organization behind barcodes and RFID tags. So we've talked a little bit this week about the Internet of Things. If you start thinking about all the things in our lives that have RFID tags or UPC barcodes, and how that might tie into a system like this, kind of cool stuff. Bunch more logos. They wouldn't all fit on one slide.
The Plum Beauty Shop.
Okay, It's 6:15. I have a section here on Sparkle queries if anybody's interested in seeing kind of how we ask those kind of questions formally. But I absolutely understand if people need to get up or want to get up and leave at this point too. It'll be fun and accessible if you want to stick around. Don't worry, I'm not going to be geeking too hard here. So for those of you who are familiar with SQL, this should look kind of familiar. The syntax is a little different, but it's basic general ideas. So I wanted to ask, what artists play the harmonica? And I'm asking this of DBpedia. The idea here is we're querying the web. So I picked some examples that would show us how to do that. DBpedia, again, is those triples that are based on the info boxes in Wikipedia. So what artists play the harmonica? And I take this bit of code and I put it into something called a Sparkle endpoint. And there are general endpoints and specific endpoints. In this case, it's a specific endpoint that is tied to DBpedia. So I'm saying, I'm going to DBpedia, this endpoint is hosted at DBpedia, and I'm asking the specific question of that data set. And it gives me a result set. That's kind of interesting. They're all blue links, so they'll all take you off to a page with a lot more richer information about those entities. What if I want to say, what artists play the harmonica and the guitar? Okay, smaller list, but I checked, it's accurate. What artists play the harmonica and the tambourine, and in what acts did they perform? Now, I'm not sure there's a website out there that covers that. There may be, but I haven't found it. So I asked this question, and I get back another result set. And you'll notice here, some of these on the right, some of the acts that people are in are blue links, and some of them are character strings. As I said before, it could be one or the other as part of your triple, particularly in that third position of the object. There's a downside to just having a character string at the end, and I'll show you that in just a minute. But still, some pretty interesting information you can get. Okay, because we talked a little bit about little data, I wanted to give a little demonstration of that. I have on my website a little 8 kilobyte text file that has RDF as the extension, and I wrote it in a text editor. Hosted on my website, and it's just information about me, the people I know, that kind of stuff. I can take a Sparkle query like this and go to a different kind of endpoint called a generic endpoint. And I can tell it where I'm going to point my query. What graph data am I going to point my query at? Put in my query and get back a result set. These are some of the people that I know. This is where we start looking at some of the data mixing, because it turns out there's another guy out there named Brian who has a faux profile, and there are a bunch of faux profiles on the web at this point. But I can point to mine and his and say, okay, who are some people that I know that Brian also knows? I can put both graphs into that generic endpoint, ask the question, and get back a result set here in the middle. So these are the ones from mine, these are the ones from Brian's. Those are people that we both know. I didn't ask Brian's permission to do this, it's open data. Here's kind of a complex query. Show me all the landlocked countries in the world with populations greater than 50,000. I want to see those country names in English and eliminate all the duplicates. Because as you know, country names can be misspelled, and particularly in places like Wikipedia, which is where I'm asking this question. Not a terribly long query to ask that information. And I get back a result set. With one little tweak, you'll notice this little @n right here. That means I was asking in English. If I go back and I change this right here in the query and run the query again, I get the result set back in Russian. A lot can be done dynamically with this kind of a data system. Because this session is titled Semantic Web for Fun and Profit, I thought it important at this point to bring some fun into it. So we're looking for these pieces of information: an episode number, air date, guest star, chalkboard gag, and couch gag. Any ideas? There are a couple hints in there.
Friends.
Not Friends, good guess.
Simpsons?
Simpsons, because everything always comes back to the Simpsons. And then order them by episode number. So I'm going to ask some questions about Bart Simpson's linked data. There's my query in the endpoint. I'm asking from a bunch of different vocabularies here. These are all vocabularies that are used, describing different things. This one right here, FOAF, friend of a friend. I mentioned my FOAF profile. That's what that vocabulary is all about. People, their interests, all that kind of stuff. DC is Dublin Core. There was an organization in Dublin, Ohio that got together a group of people and decided on 15 terms that could be used to describe scholarly articles originally. And then they expanded it. They didn't expand the vocabulary. They just expanded what it could describe because they found that things like title and author and contributor were relevant. Okay, so here are my results. Episode number, air date, guest star, chalkboard gag, couch gag. One large one here. So this you'll see as a blue link. And here you have Kelsey Grammer and Diane Tanaka. Now, the blue links are really interesting from a development standpoint. If someone wanted to use this data to build something, the blue links are really interesting because this Kelsey Grammer as Sideshow Bob ends right there. There's nothing more you can do with that. It's a character string, so you could make it look pretty and that's it. But with George Takei, once you tie into that, you could actually jump off to this entire page about George Takei and all of this rich data about him. His birthplace, his birth name, this description of him. Just amazing stuff here. Lots of rich data. So the last thought I'll leave you with regard to semantic web, is back to a harmonica metaphor. And that's that a little bit can be very powerful. I don't know how many of you recognize this song, but listen carefully to the harmonica riff. It's 5 notes. And it's one of the most recognizable harmonica riffs in the world. And the second you hear it, you know what song that is. And it's extremely powerful. And the same is true with semantic web. It's easy to go down a rabbit hole really fast and get lost in the weeds. But just by putting a little bit of data in there, store hours, lat long codes, what's the information on your page? What is your page about? You can derive a lot of power. So that's me. This is where you'll find me during the day, semanticweb.com. It's a news site. My consultancy, semanticfuse.com. We help people do this kind of stuff. And we have a conference coming up in August all about semantic technologies taking place in San Jose. So that's me. Thank you all very much. If you want to reach out, if you have any further questions, please feel free to connect. And thank you. Question?
Sorry if this was addressed earlier, but when you're synthesizing data from all these data sources, how do you address veracity? You know, what's the authority? If different people can tag things if they know the language.
Sure.
Does that create conflicts or ordering or, you know?
Excellent question. The W3C has just recently been hard at work on something called prov, and prov is provenance. So that carried with each piece of data, you can actually tie the provenance to it. You can say, this is the source of this information. And that's really becoming valuable. The Getty Museum just released several of their vocabularies describing artifacts in their collections. And they're very interested in provenance. The library community, Library of Congress, is looking very seriously at this because they're looking to replace something called MARC records. MARC records are the things that libraries have used for 40 years to describe all the resources in the libraries, the books, the microfiche, all this stuff. And they are replacing those with linked data. So they're using provenance to do it. And prov is built on the same structure of triples. So it's a very plug-and-play answer.
What percent of the web pages use RDF?
What percent of web pages use RDF? It's usually in the form of microdata or RDFA, and a gentleman at Google recently reported that, I want to say it was like 15% were using it at this point.
So you're missing out on 85% of the data, but it'll get less.
Yes, I mean that's the idea. Schema.org was a huge game change because suddenly you had the value proposition to the web developers. They want to get discovered by Google, Yahoo, and Bing. SEO. So the SEO community has taken big note of this, and they're paying big attention. They don't always get it right. They don't fully understand what they're supposed to do, but they're absolutely paying attention to it.
So if I'm reading the newspaper and it says such and such a person, politician, said this about whatever, today's little news bite.
Yeah.
And I think to myself, well, that's interesting, because don't I remember, like, a month ago he was saying something different, or what did other people say about it? And those kind of relationships, it seems like somebody's going to have to spend a lot of time going through texts and marking pieces of information with this useful tag. Is that ever going to happen? I mean, it seems like totally, almost infinite.
So two things. One, will it ever be done? in the same way the web will ever be done? No. But there are an increasing number of tools allowing people to do this. There's one by Thomson Reuters called Open Calais, where you can take a block of text, put it through this tool, and it'll pull out the entities. It'll recognize, in this thing that's probably about an acquisition, Microsoft bought this company. Well, it may not recognize this company. Maybe it's Microsoft bought Little Labs. Well, it doesn't recognize Little Labs because this newspaper's never reported on it, and Thomson Reuters may have a record of Little Labs before. But because of that relationship Microsoft acquired, it knows, well, I know what Microsoft is, and I know what an acquisition is. Therefore, this is probably a company entity, and with a good degree of certainty, I can say that that is a business. It's a type of business. Don't know what type, an S Corp, LLC, I don't know, but I can make that assertion. So the machines can start to make inferences when you do this as well, and there's some really interesting reasoning projects taking place.
So if I have a question, how do I know where to search besides DBpedia? Is there a catalog of catalogs, basically?
You can, there are catalogs of data that are out there. You can check out linkeddata.org to see some of the data sets that are out there, the linkable data sets. But you can also increasingly use search engines to ask questions. Google has created something called the Knowledge Graph. A few years ago, they bought a company called Freebase. And it's a company that had just this massive database of entities. And Google, with its Knowledge Graph, is displaying things on the right side of the page now that didn't used to be there. So if you do a search on Van Gogh, for example, or Frank Lloyd Wright is perhaps a better example. It's going to assume you're looking for the Frank Lloyd Wright, the architect, and it's going to give you quick access to his blueprints, his houses around the world, and things like that. And it does that by using inference, and you can ask a pretty complex question now that you couldn't do earlier with Google. Historically with Google, if I type in MOLE into a search engine, I'm going to get back results about small furry animals, something on your skin, spies, a Mexican chocolate spicy sauce, all kinds of things.
MOLE?
Yes.
Oh, it's awesome.
Yeah.
Mole.
Yeah, I love it. It's one of my favorites. I just had a white mole for the first time. It was really interesting. Anyway, but that has been search for a very long time. And now we can start to disambiguate a little bit because the search engines are doing it for us.
Is this some level of machine learning?
Machine learning is involved in some of the same systems that use semantic web standards. You know, you see, semantic web standards have been used in systems that have used other semantic technologies. Things that I put in that broader category include things like machine learning, text analysis, natural language processing, you know, things that help systems understand. But semantic web standards are this very specific set of things. Some of those systems would be Siri on the iPhone, Watson, IBM's big computer that won at Jeopardy and is now helping with healthcare. So it's usually used in combination with things like machine learning.
Are you having fun?
I'm having a ball.
So here's another thought. This is a little inquiry I had. I noticed that the weather forecast in the newspaper seemed more accurate a week ago than it was yesterday. In other words, the prediction for today's weather got worse over the intervening period. And I, at one point, actually cut out the little diagrams from the paper and lined them up, you know, like this, and looked. How would I do that electronically with what you're talking about, or what Russ and you guys are doing? Is that kind of data, looking backwards at published stuff in a way, going to be? Is it available now? Is it going to be?
So one of the things I really love about this set of technologies is the balance it has between machine processing and human curation. It really elegantly allows for both. The New York Times is using this. They've had an index since 1851 of things around the country, and it's been a trusted source since then. They've now made that available as this linked open data in that format. If you trust the New York Times as a source for that information, you can continue to trust the New York Times as a source for that information. They went through one of these elegant processes where their way of turning this into linked data was to pull up a dual screen in front of a human being that said, here's the thing from our index, Kansas City, and here is that thing that we think you're looking for from a linked data set of geocodes. And do they match? And a human could say, no, I meant the Kansas City in Kansas, and make that connection and say, that's the one I meant. And then that human did the curation, and it's linked forever in the New York Times data set until someone comes along, an editor comes along and says, that's not right, and changes it. But it's got this very elegant way of working with it. So long answer to your question is, how do you do that? You find a trusted source. There's no big entities saying that the information at the New York Times is more trustworthy than the information coming out of Fox News. If you prefer one source over another for your weather or any other information, you can continue to trust that source. And if you're an application developer and both have their information available as linked data, you can use either one. So, sorry, there's no canonical reference for weather yet. I like the National Weather Service myself, but.
You know, something I realized in the new operating system of Apple, now you have the ability to add tags to any file you own, and it's great. It's awesome. I have the sorry, I forgot the name, but I used to keep my links in my desktop. I like something, I grab the link and save it as a weblog file. When I want to find something in my own computer of something I like, it's barely impossible. It's in something I already looked at. So now with that, I can easily say, this is for Facebook, this is for social media, this is
Yeah.
for development, this is for personal, this is for, and I just look at all the files that have that metadata of anything. And it could be a PDF, a link, a Word document, a picture. It doesn't matter, because as long as I have Semantic, I can access it
Yeah.
more easily. So I wanted to share something about what you said.
Thank you. That's great.
Thank you, Eric.
Okay, well, thank you. This went way over time, but thanks for sticking around.